Next, we're going to define, I'm not going to do these yet. I'm going to define two helper methods, which are going to sort of help us write tests, or I'm going to be running tests alongside of this. So the first one is going to be called toList. So it's going to need to be recursive, and it's called toList. And this just takes a sequence of A's, so a T of tick A, and returns a list of tick A's. So this is going to be pretty useful for converting between regular data types, to and from sequences. So all right. So if we're given a sequence, then let's actually write this function. If we're given a sequence, so the sequence is a function, so we're going to need to do something. We're going to actually need to call this function. I'm going to wrap this inside of a switch block, switch expression, whatever it's called. And we're going to sort of pattern match on the result of calling this function. So once again, a T of A is a function that you pass 0 parameters to, and it gives you a node. And these nodes are either nil, and if we were just to call this this function and get a nil back, well, that just means that seq itself was like an empty sequence, or sort of, yeah, it was like this right here. So we should just translate that to an empty list. Okay, so that's pretty easy. The more tricky part is if we get back a cons, and let's say that it has some element x in the first position, and then the rest of the list is here, the rest of the sequence is here. If we get that, then we should build a list containing x, and then in the rest of the list, this is the list cons syntax. So if I have something here that's a list, that'll get consed on, the x will be consed on to the front. So in this case, we're going to make the recursive call, and we're going to say toList of the rest. Okay. All right, so that's type checking, which is a good sign. And I believe that'll work. Let me just check my notes. Yeah, that's what I had previously. Okay. All right, cool. So yeah, so this will actually transform our sequence back into a list. All right, and then we're going to write the analogous function, which is called ofList, so sort of from a list to a sequence. And this will be useful for actually getting a sequence in the first place. This is going to need to be recursive, and its type is going to be from a list of tick A to a T of tick A. Okay, so we're given a list. Let's see, what can we do? We should probably pattern match on it. Let's pattern match on the list, and then if we're given an empty list, then we should just return the empty sequence. So notice I'm not returning nil, because nil is not a T of A. That nil is a node, and a T of A is a function. So I could either write this like this, or we already have that built up, and this is a lot of arrows, so I think I'm just going to refer to the empty sequence here. Okay. Or it could be something that contains an x and a rest. And if that's the case, so if we have a non-empty list, then what we ought to do here is build up a function. So we're returning a t, so it's got to be a function. And we're going to use cons. We're going to put x in as the element type. And then what we need to do here is, I believe we can just recursively call ofList, not that, ofList on rest. Okay, that type checks. That seems reasonable. So what's happening here is we're creating a new function, and oh yeah, this is actually interesting. So this says this is a recursive function here. It's not quite a recursive function like we normally think of as a recursive function, building successive stack frames on the stack. really the only reason we have this rec up here is because we're referring to the name of list down here. But this is actually a lazy function in that when you call it, so if I actually call this on a list, not much is going to happen. It's going to create this first function and say, okay, when you need to get the elements out of this sequence that I'm creating, then we'll call this function, and this of list of the rest will be generated at that time. So that's sort of interesting that we're not really going to have Stack Overflow here, I believe, because this is sort of broken up into pieces because we're like returning a closure that does the recursive call.